So now, let me put this up here. Oh, the image is gone. Let me sort this out. So what I've done is I've connected up all the I2S lines and the audio out. So I'm just basically going to check the DAC. So there should be a certain number of signals on this guy. So let's see if we can do this where it makes sense. So I'm going to probe these guys here. So let's see what we got. So the first thing is the master clock, and that should be 11 point, I think I can't remember, 29 megahertz. So it's close enough. It looks reasonably in good shape. So I've only terminated the master clock. Next is the left-right clock. Actually, I'll do the bit clock. So that should be slightly slower, but again, a fixed clock. Then we'll have our left-right clock. And then we'll have our data in. So these are the I2S values from the ADC and our SD out. So that's after being filtered, it comes out through the DAC. So all the signals appear to be there, not sure about the integrity of them. So then so basically I've just connected the audio out from that. So if I just load up KiCad here, so we're basically just looking at this portion here. From here. So we have our ADC in, go to the I2C into the ESP32 and back here, and out from the DAC. And I'm just bringing one of these to the audio. So these are all open circuit at the moment. So let's turn on the audio and see how we get on. So let's. There's a little bit of a whine there. Probably the easiest way to test this is that you just put your finger on a pin, and you can. It's picking up the mains hum. And realistically, I can't hear any distortion there. I'm not saying there isn't, but yeah, doesn't seem too bad at all. So then, what I'm going to do next is put the toroid in. So it's a trifler wound toroid, so 3 wires kind of wound together, and then 10 turns in the toroid, and it's inserted. So 1 here corresponds to 1 here, 2 to 2, 3 to 3. So the 1 wire within the toroid will go from, let me get something bigger, smaller than my fat fingers. 1 wire should go from here to here, next one there to there, and lastly there to there. So let me get that done, the toroid installed, and see where we go from there. So just want to have a quick look at the toroid here to explain the way it works. Hopefully you can get a decent image of it. There's the focus. So there. So we have 3 wires, and you just basically wind them around each other, and then wind it around the toroid. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 turns, not 10. I believe 10 would work just fine as well. And so in this case, this wire is connected to this is connected to this is connected to this. And that's how they're to be installed in the actual board itself. Let me just put this in here. So it'll go in like this. So those 3 there, and then you can get those 3 in there. So I just get them installed. Okay, so I've soldered the toroid in, and I'm now feeding in a signal generator into the input here. So this is testing the analog side of things. So let me just put up kite head here. I have to move my coffee. So we're basically feeding the signal in here into the splitter. That's going into the mixer and to the output. So we're going to look at the outputs here, just to see if this section is working. So do this, and definitely be up there in frequency. So this guy. So we're going to probe these, the I and the Q output. Let me put this onto AC. So a lot of noise there. Okay. Let's have a look here. What are our settings? Just going to probe these again. Oh. And the regulator is getting really hot, so that's not a good thing. And one of the diodes is getting quite hot as well. So I need to dig a little bit deeper and see what's going on here, and then I'll come back. Okay, so I had a look, and yeah, the regulator is getting hot, but I don't think it's actually a major problem. The problem was my input into the mixer, I think, was too low. But let's see. So plus or minus 5 here, and we will on the probe the output of the 2 op amps here. And yeah, so I'm going to probe. I know the image isn't great there. So here's our. So let's power this up. And see what we're looking at. Okay, so we got a signal there. Oh yeah, the reason it's so we're getting an output of a sine wave there around the 2.5 volts. And we're getting an output there. They should be 90 degrees out of phase. I'm not going to check that right now. So the next thing I'll do is just put in the connections here. So ultimately what we're trying to do here is we want to connect the output of the mixer and low pass filter amplifier to the analog to the digital converter. Then we want to connect the output of the DAC to our op amp here, and this to the audio. I'm not going to go through each section. I'm just going to put the jumpers in and see what happens. I think the reason the op or the regulator, where's the regulator here, is getting hot is something to do with the change I made here. The nice thing about it, I can just short this and remove the diode, but I'm not going to do that yet. I'm just going to live with this getting hot for a moment while I just test the rest of the circuit. So we shall see. So I'll just put those jumpers in. Take the audio out of there. So I'm going to bring the clock down to 7 megahertz. And let's be really confident. Let's put the audio straight out and see what happens. So we got liftoff. Although the volume seems quite low. And the sideband is being suppressed. Not great, I'll have to balance it out, but so we got some life out of it. I don't think it's perfect. Oh, I actually know why it's not perfect. I messed up, I think. Let me see. Did I change these? I didn't. In the previous prototype I had changed these two resistors, the gain. I think I changed them to, I actually can't remember. I'll have to actually have a look and see. And once they're changed, you get a lot more gain here, and then the volume and everything is way better. So yeah, that looks good. It's not perfect because it's getting quite hot. Not crazy. Let me just check the diodes here. Yeah, they're getting hot as well. So I think the resistor that's going to the diode, I can drop that, and that'll drop the current throughout the entire system, which should fix the regulator as well. So hopefully just change two resistors and for the power and two resistors for the op amp, and we're good to go. I'm just gonna power down and power back up again and just see how the balance is. So hope you can hear this. bring the mic over closer just in case. So this is what should be gone. This side of the and I'm just adjusting the pot. I have no idea where this pot was set. Let's see. I'll go all the way in one way. It doesn't seem to be doing anything. That doesn't seem to be doing anything. So there we are. So now let me see. So that's getting louder. And lower. That's gone. Yeah, so it's working. It just needs. Okay, so I think electrically it's working. It just needs to be adjusted, and so I think we're on a winner. So good. So I'll just make a few adjustments to this, change a few parts, and then we'll come back and see how it's going. So just to show you, I put the new board and the old board side by side, and these are the resistors that are used for setting the gain. So I'll just zoom in on them. So these are 10k resistors, which, to be fair to, I got it done with JLC. To be fair to them, they built it exactly as I specified. I found in the previous one that it wasn't enough, and I forgot to change it on the schematic. So this is what I had in the previous one. Forgive the more you zoom in on this, the worse it looks. So it does. Anyway, so they're 18k resistors. So I'm going to change them first, and just make sure that we're getting the proper audio out. I would think that I should, because I made very minimal changes to this. I increased the hole size for the toroid a little bit so that the wires would fit through easier, and just fixed some stuff up on the cell screen and that, but that was pretty much it from what I remember. So if I change them, I'm pretty sure I'm going to get the same as the previous board output, which was really good. You could hear down to about 125 minus 125 dB, which is more than adequate. It's going to be a lot lower than the band noise. So okay, I'll get that done. So I'm continuing to debug here, and I was trying to balance it, and it really balanced with one frequency. It was really weird. So I decided I better dig deeper. So when I look at these, so that's one of the inputs. That's the second one, so both of them are fine. And on the output then, it's going to probe here, we should have similar signal. Can't remember, I might have put a bit of gain into the filter, it looks like I did. But on this output, it's severely attenuated. And I'm not sure if it's just picking up crosstalk from the other one, or it's actually seriously attenuated. So there's something wrong between this and the ADC, I'm suspecting, because the data here, once it's right on one channel, it means all the connections are right, because the data comes on one pin. SD in, where's SD in? This guy here, and once it's right on that, if it's right for one channel, it kind of has to be right for both, because then you just have a left-right clock. So I think that there's something wrong between here and the ADC. Some connection isn't being made properly, so I need to dig into that and get that sorted. The good thing is I did replace the resistors, and let me just pull this over here, turn that down. So even at minus 100 you can hear it fine. It's quite noisy, but the filter in the ESP32 will clean that up. So from what I can see, the analog side is working fine. There's something when that goes into the ADC as well. So I'll dig more and see what I can find. Okay, so guess who's the complete genius around here? I normally do some silly things, but this kind of takes the biscuit. So I'm looking for glasses here as we speak. So I think I've got to the bottom of it anyway. So eventually kind of followed it through, and I think what I was looking at there was a bit of a red herring. I'm not actually sure, because it's working fine now all the way to here. And then this non-inverting op amp, it's where, so I've nice signals here, and then it's severely attenuated here. And I'm looking at it, I'm saying, I have 2.5 volts here, I should have 2.5 volts here, and this just unity gain, and I have a 10k pot, so if they're the same, that should be balanced and out. And the circuit is perfect, except for one, the most stupid thing ever. I forgot to power up the op amp. So you notice here, I powered it up over here for these two. It's a dual op amp, and forgot completely to power this guy up. Probably if I had done which I generally don't do for hobby stuff at all, if I set up a proper electrical check on this, it would have picked it up. But I'll be honest, for hobby stuff, I don't do it. I kind of say no. It's quicker, easier, faster. Get the boards back and debug them. But the good news, all is not lost by any stretch, is the two pins, pin 4 and pin 8. So pin 4 needs to go to ground, so that won't be hard. I can just put a little solder bridge across that. I'm quite good at doing that, even when I don't want to. So there's no problem there. And then realistically, it's to take a 12 volt to this pin here, and I just run a little wire along from somewhere where there's 12 volts. Not exactly sure where, but anyway, there's loads of 12. It comes in up here. If I had to run a wire the whole way down, I would, but I'm sure there's one closer. Actually, yeah. So here's a 12 volt line, So probably from R1 here, or I might just take it from this track here over to here, on a light line, and that should do the trick. Yeah. Okay, that explains a lot. I was really chuffed. I thought I had everything perfect, but the balance was just funny. And it sort of when I measured the voltage divider on the op amp, I got 1.77 volts. I'm like, that doesn't make any sense. It should be close to 2.5 volts. And started looking here, and then it was like, there's no power. So, okay, that's where we are. So let's get this guy powered up, and hopefully that's it. Cheers, folks. Okay, so I put a blob across that to ground pin 4, and I ran this guy to the plus 12, and saw a nice sine wave coming out of this and thinking everything is great. But we're not out of the water yet, unfortunately. This one isn't giving it up easy. So at the moment, what I'm doing is I'm looking at the two inputs here, and then the two outputs here. So what I thought was solved, where one of the channels seemed to be down and the other isn't. So I'm going to start with the two outputs here, which is the input to the DAC, or the ADC, and then the output from the DAC. So let's do this. So with the picoscope, actually, just so you can see where I'm probing, hopefully. Yeah. So these are the two outputs, the I and Q, and they go into these two pins here, pin 6 and pin 8, and that connects to pin 8. So this is pin 6, and we're looking at, what is it, 115 millivolt peak to peak, and then minus 60 dB going in, minus 61, and it's close enough. And this is the other input, so 118 millivolts, and then go back to the first guy, 115, it's a couple of millivolts in it. So if that's the case, you'd expect on the output, we'd have the same of the DAC, but on the DAC output, we have, I need to, 264.65 on the left channel, and on the right channel we have 166. So somewhere along the line it's getting missed, and I'm not sure why. I didn't have that problem on the first board, so, and there has been some change. I've moved the components and so on. So this is the, if I can zoom in a bit further here. So these are the outputs. To C20 and C21. And I was probing here and here, and this guy is down low relative to this guy, and it doesn't make sense. So basically when I probe here, I get the right signals, and when I probe here, the out right is significantly down on the out left. So that's what I need to figure out. So what I'm going to do is I'm going to lift these capacitors just to totally isolate this chip here, on the basis of possibly something is populated around here or something like that, I'm not sure. And then I will measure it here, because we're really into the digital development at this stage. I better check the software as well to make sure this is something stupid that I made some change in that. But I don't think so. Just actually have a really quick look. Yeah, so it should be either, yeah. Oh gee, look at this. Oh, I can't believe I did that. Now, I have a different filter on the plus and on both channels. Now that makes sense. That why one would be different to the other. Doesn't make sense why it should be different, but it makes sense that it would cause this exact problem. Well, that's a lot easier than hardware having to do that stuff. So let me get this guy going again, and maybe it's there. So let's do this. So on Linux, I can set it up, but every time you plug in the USB, it's owned by the administrator and not by a general user. So you have no access to USB as a general user. But you can edit a script or a file, and it'll give you access. I just haven't done that yet. So here's fingers crossed. Now. So I'm looking at output 1, 248, sorry, 243. Okay, that's looking better. So I'm now going to put these in here, or these are the jumpers, and not sure if you can hear this okay, but there's definitely some sideband situation going on. It's quite poor and it needs to be balanced. So let's see if we can do that now. So that's the lower sideband. That's the upper sideband. So okay, so I'm going to just so that's the upper sideband. You can hear something. And that's the lower sideband. Okay, so after lots of fun and games, we're good to go. So there's one wire link needed and a blob across 2 pins, and other than that it all seems to be good. So let's just. So that's at minus 100 dB. Not sure if you can barely hear it there. It's at minus 111 dB. It's quite obvious that it's there. Even at the minus 120, I can hear it, but as I say, I'm not sure how well the mic can pick it up there or not. Okay, so there's the adventures of debugging a board and a few very stupid stuff, especially on the having two different filters, which resulted in different amplitudes in the output and lots of different things. So that would definitely not help. Probably the stupidest mistake was not powering up this op amp. Thankfully, it's easy enough to fix, but yeah, I'm a little bit embarrassed about it. So yeah, what I'll do then is I'll put an aerial on it later and see how it goes. It's about what time? Yeah, it's 4:47 in the afternoon here, and the band is probably pretty dead. So I'll wait till the band comes alive, and then I'll put the antenna on it, and we'll see where we go from there. So I actually just tried the band there, and there was a bit of Morse on the bottom. I didn't check SSB so far. So not sure how well this will show or not under the camera. Not very well. So if I reset the system, it's going to come up with the SSB filter. Then if I press this button and reset it at the same time, come up with the Morse filter. Makes a massive difference. It's great. So let's just while I'm here, check the SSB side of it and see is there anything there. Doesn't look overly promising. Okay, there's a little bit there. So I'll go to the lower or the upper sideband of this. You can barely make out the something there, but it's virtually in the band noise. Oh, maybe he'd stop talking. So I'll go to the upper sideband of this guy. So that's about 0 beat. And you really can't hear anything there. But the band is very poor at this time of day here, so at even time, night time, it'll it'll come alive. So I'll do some more testing of it then. That's all for this one. Catch you later.